An ice sphere the size of a house silently collides in the orbit of the golden giant. Why shouldn't the most famous structures in the solar system be there? The instruments of the Cassini probe revealed a mathematical flaw in the age of Saturn's rings. The classic image of the sixth planet suggests an ancient, unwavering order, a pale gas globe surrounded by a perfect disk floating in the absolute dark of deep space. But the visual perfection observed by telescopes hides a violent and continuous kinetic environment. The ring system isn't a solid track of matter. It's a perpetual motion debris field, a circular storm of frozen detritus. Billions of ice fragments spin at speeds exceeding 60,000 kilometers per hour. They range from invisible dust grains to irregular blocks larger than entire mountains. Each piece orbits alone, collides with its neighbors, fractures into smaller bits, and regroups under the relentless gravity of the central planet. For 13 years, the Cassini space mission mapped this chaotic choreography up close. High-resolution cameras recorded density waves rising like miniature galactic spirals. They observed small shepherd moons like Pan and Daphnis carving dark gaps through the ice as they orbit. The structure's complexity seemed infinite. Everything seemed to obey the laws of orbital mechanics predicted since the time of Galileo Galilei. The mission was about to conclude with a final controlled dive into the planet's atmosphere. In April of 2017, the probe began its disposal trajectory, and it was during this silent, suicidal dive that telemetry sent back an impossible datum about the very nature of the planet. The mass pulling the capsule to its destruction defied the logic of its own scale. Equatorial bands of liquid ammonia swirl in continuous storms that cover the area of entire continents. Saturn dominates space with a diameter of 116,000 kilometers. It's the second largest world in our system, vast enough to swallow 700 Earths in a single gulp. But the mass contained within this colossal volume tells a completely different, counterintuitive physical story. Saturn's average density is only 0.69 grams per cubic centimeter. For comparison, pure water has an exact density of 1. If there were a cosmic ocean large enough in the universe, Saturn would float on its surface like an immense cork block. This extreme lightness occurs because the planet is almost entirely composed of primordial elements. Hydrogen and helium form the overwhelming majority of its structure. The same light gases that make up the sun, but not compressed enough to ignite the fire of nuclear fusion. In the planet's deep, inaccessible core, overwhelming atmospheric pressure transforms the gas into liquid metallic hydrogen, an incandescent, dense core that generates a magnetic field 500 times stronger than Earth's shield. This metallic ocean spins at a frantic pace, completing an entire day in just over 10.5 hours. The accelerated rotation visibly flattens the planet's poles and violently expands its equator. Saturn isn't a perfect sphere. It's an oval globe distorted by its own inertia. And this gravitational deformation creates the perfect physical stage to anchor matter around it. But the bizarre light composition of the gas giant was merely the structural prelude to the mystery orbiting just above its clouds. At a higher altitude, above the ammonia clouds, the brilliant disk of ice stretches 282,000 kilometers into the vacuum. The total width of the ring system would fit almost perfectly into the exact distance between Earth and our moon. It's a structure so vast and imposing that it completely dominates the planet's night sky. But the formidable horizontal scale hides a vertical fragility taken to the absolute extreme. If you could fly there and observe the rings perfectly edge-on, they would practically vanish from your sight. The main disk's average thickness is only 10 meters. It's the equivalent of a sheet of paper floating on the gigantic scale of the solar system. And the physical composition of this thin sheet presented the first insurmountable problem for planetary scientists. The Cassini probe's onboard spectrometers confirmed that the rings are 99.9% pure water ice. They shine intensely under the distant illumination, reflecting direct sunlight like fresh fallen snow on an open field. And it's precisely this pristine crystalline brilliance that breaks accepted mathematical models of planetary formation. The interplanetary space between the giant worlds isn't a clean or sterile environment. It's constantly traversed by dark dust clouds, fragmented micrometeorites, and the remnants of ancient carbon-rich comets. This cosmic soot falls continuously and mercilessly upon absolutely everything orbiting our Sun. If Saturn's rings had formed along with the planet's birth 4.5 billion years ago, they should be completely dark today. The pure ice should have already been stained, polluted, and covered by a thick layer of black rocky material. The rigorous mathematics of space pollution demanded that the rings be opaque and dark, resembling crushed coal orbiting in the void. But Cassini's final risky reading contradicted all the chronology established by astronomy books. The probe's main parabolic antenna pointed fixedly towards Earth as it crossed the narrow gap between the rings and the planet's atmosphere. During 22 low, dangerous orbits, the radio instruments measured the gravitational pull of the ice disk in isolation. The total mass of the rings proved to be surprisingly minuscule. The combined weight of all that material was equivalent to only 40% of the mass of Mimas, which is already one of Saturn's smallest moons. This extreme lightness in the telemetry data, combined with the pure brilliance of the water ice, forced an inevitable scientific conclusion. The rings we see today are not ancient. They didn't form in the chaotic dawn of the solar system along with the planets. The measured rate of micrometeorite pollution indicated that this brilliant ice had only been exposed to space for 10 to 100 million years. What destroyed an entire moon to paint Saturn's equator with pure ice? During the Cretaceous period, while great dinosaurs still walked the surface of Earth, Saturn's sky was completely empty. The planet was just a massive golden globe with no adornment around it. The abrupt discovery transformed the rings from a permanent geological feature into a recent, transient, and cataclysmic event. Something massive and extremely rich in water orbited the giant planet until a cosmic fraction of a second ago. And computer models of dozens of universities had to be rewritten from scratch to find the missing body that supplied billions of tons of fresh ice all at once. The digital simulation of a Titanic impact ran without interruption on the supercomputers of the Massachusetts Institute of Technology. physicists input the current mass of the orbital system and rewound the gravitational clock 100 million years, the answer emerged in the form of a ghost moon, an extinct world that scientists christened Chrysalis. Chrysalis was approximately the size of Iapetus. It was composed of a deep, dense, rocky core entirely covered by a thick mantle of frozen water. For billions of uninterrupted years, it orbited Saturn in relative quiet stability. But the complex mechanics of the solar system are shaped by invisible resonances that operate on colossal timescales. Saturn's largest and most massive moon, Titan, began to slowly migrate away from the planet's pole. This subtle millimeter-by-millimeter orbital movement pushed Chrysalis into a lethal gravitational dance with the orbit of distant planet Neptune. The ice moon's trajectory became unstable and chaotic, dangerously elongating with each new pass around the equator. Until, on a specific, violent day in our system's prehistory, Chrysalis plunged too deep into the giant's gravity. It crossed Saturn's invisible Roche limit, the critical mathematical distance where the planet's pull tugs on the moon's closest face with far greater force than its distant face. The relentless tidal force shattered Chrysalis into billions of pieces in a matter of hours. The heavy rock core quickly sank and was devoured without a trace by the gas giant's atmosphere. But the light mantle of pure ice, dispersed by the destruction, remained trapped in orbit. The frozen fragments collided with each other millions of times in the dark, grinding entire mountains of water until they formed the brilliant, flattened disk we see today. The violent death of an entire world generated the most beautiful crown in our cosmic neighborhood, a crown of debris that carries its own expiration date etched into its delicate structure. A continuous rain of microscopic water crystals cascades onto the golden planet's upper atmosphere. The final deadline for the ice structure is already being meticulously recorded by terrestrial observatories. The rings aren't just spinning around the planet, they're actively falling towards it. Ultraviolet radiation emitted by the distant sun electrically charges the disk's finest, most vulnerable ice grains. Once electrified, these crystals are instantly captured by the gas giant's immense magnetic field. The frozen water spirals rapidly downward along invisible magnetic field lines, combusting in the upper atmosphere. It's a documented phenomenon known to astronomers as ring rain. 10 tons of material fall on Saturn with each passing second, silently draining the disk's mass forever. Why shouldn't the solar system's most famous structures be there? Because they're merely the temporary debris of an orbital accident, a disintegrating ice phantom that humanity is having the rare, fleeting privilege to observe. In about 100 million years, the relentless rain will consume the remaining material, and the golden giant will once again be completely bare in the dark of space. In our next episode, we'll investigate Jupiter, Earth's protector, who swallows comets to save us, a gravitational monster that draws the destruction of the solar system to keep the rocky planets intact. For now, the last particles of the moon Chrysalis continue to reflect the distant light of the sun before silently sinking into the dense ammonia clouds.